Hello, Algebra 2. Here we are with our 1A review worksheet. Okay, we did half of it in class. So we're going to work through that half here on the video just in case you were not able to attend class today. We had solved by graphing, solved by substitution, and solved by elimination before working on matrices. So let's get started with solve by graphing. Okay, so we have y equals x minus 5. Already in a friendly form, slope-intercept form, we're going to start at negative 5. 1, 2, 3, 4, 5. And then our slope is 1x. So we're going to go up 1 over 1. And we'll get a handful of slope dots on our graph. And we'll use a straight edge to make a nice line. Okay. Next one, x plus y equals 9. Would not be terribly difficult to get into y equals mx plus b form. Okay, we could just subtract that x over. And we could graph it just like the top one. This is also kind of in a friendly form to do the intercept or cover-up method. If I would try to find the y-intercept and plug 0 in for x, x is gone because it's 0, and y would be 9. So 0, 9. And then if I want the x-intercept, I plug 0 in for y, and now the y is gone because it's 0. And x equals 9. 9, 0. Okay, so we got 0, 9 and 9, 0. Or we could also go with the normal y equals mx plus b method there. Okay, we graph that. And we cross at 7, 2. We should be able to check our answers and plug 7 in for x. 7 minus 5 is 2. 7 plus 2 is 9. It checks out. All right. Next, we're moving on to substitution. Okay, so we have x equals negative 2y plus 8. Negative 2y plus 8. And we're going to plug that in for the x. So we'll have 2 times negative 2y plus 8 plus 3y equals 11. Distribute your 2. We'll have negative 4y plus 16 plus 3y equals 11. Combine our y's together. Negative 4y plus 3y. We got negative 1y. We'll minus 16 from both sides. Negative y equals negative 5. Positive y equals positive 5. We're going to take that and we're going to plug it back into this one. The x equals, we're going to plug it in for y up there. Negative 2 times 5. So we'll have negative 10 plus 8. We'll have negative 2, 5. And again, you should be able to check those by plugging them in for x and y, and it should work in both sets. Last one on this side, elimination. Okay, 2x plus y, 3x minus 2y. There's no wrong one to cancel out, but it's easiest, I think, to cancel out the y's. Partly because one's plus, one's minus, and partly because we have a single y. So then I can just look at what this is and multiply that whole row by that number, opposite sign, so that it matches and cancels out. So we're going to multiply that whole top row by 2 to get 4x plus 2y equals 6. Make sure you take it to the equals and get that equals 6. Okay, we're going to add down. (7x equals 21). X equals 3. Okay, and we can pick any of the equations up top to plug that back into. I'm going to go all the way back up top to the one that we have kind of squiggled out. 2 times 3 plus y equals 3. 6 plus y equals 3. Y equals negative 3. So we should have 3 comma negative 3. Okay. On to the back side. Are they inverses? So we had previously talked about just multiplying these together, and if it's 1, 0, 0, 1, then we know they're inverses. Okay, on the test it's going to ask you to show it both ways, kind of as a check. For square matrices, if it works one way, it should work the other way. But we're going to show both ways just as a self-check there. Okay, so we need to see A times B equals 1, 0, 0, 1. And if it does, we need to turn it around and show that B times A also equals 1, 0, 0, 1. Okay, so I think in class we did the top one, it was a no. Bottom one's a yes. Let's do the bottom one just to show you what we're looking to see here. I'm going to have to write small just to make it fit. Okay, so row times column. Okay, we have 2 times 4/3 and 1 times negative 5/3. That's going to be 8/3 minus 5/3. And that's going to be 3/3 or a 1. Row times column, we'll have negative 2/3 plus 2/3. That's going to be 0. Bottom row, left column, that's going to be 20/3 minus 20/3 for 0. In bottom right, we've got negative 5/3 plus 8/3. 401. Hey, how about that? 1001. Check. Now, because it worked that way, we got to turn it around and make sure it works the other way. So now this one's in front, and that one's second. So we got 4/3, negative 1/3, negative 5/3, 2/3 times 2, 1, 5, 4. Okay, row times column, 8/3 minus 5/3. And it looks like we're off to the same start. That's going to be 3/3 for a 1. Okay, not all of them are going to be the same. I think we start getting different work here now. Row times column, 4/3 minus 4/3, different from before. Okay, we didn't have any 4/3 in the other one, but that's going to be a 0. Row times column, negative 10/3 plus 10/3. Again, a totally different fraction than we had in the other matrix. So it will be easy to tell if you are actually doing this, because the work is not necessarily always the same. And row times column, we got negative 5/3 plus 8/3. For positive 3/3 or 1. And we got 1, 0, 0, 1 again. Solve using inverses and matrices. So step 1 is to change this into some matrices. 6, negative 3, 3, negative 1. Times x, y equals our answer side, 12, 7. Okay, now to solve, it's just like a regular equation. We got numbers times a variable equals the answer. You would do the opposite, or the inverse. So I need to do the inverse of this matrix to both sides. So now I need to find that inverse. Step 1 is to get the determinant. That's the difference of the diagonals. So 6 times negative 1 and minus negative 3 times 3. Minus a negative. So that's negative 6 minus negative 9. Minus a negative is really a plus. So negative 6 plus 9 is 3. What do we do with that determinant? Okay, it's 1 over determinant times, do you remember what we do for our switcheroos in here? These two switch places, and these two change their signs. And then we multiply that 1/3 in. Negative 1/3, 1, negative 1, 2, and that is the inverse. And now we're going to put that in the front on both sides of the equal sign. All right. In our original matrix equation. Okay, and we did this the long way one time in notes, and one time is enough. And then we showed how these canceled out. And we have x, y equals, okay, row times column. So we're going to have negative 1/3 times 12 and 1 times 7. Negative 1/3 times 12 is negative 4 plus 7 is 3. Row times column, negative 1 times 12, 2 times 7, that's going to be negative 12, and a 14 for a 2. 3, 2. And we should be able to take those all the way back to the top and double check those in your original problem, or your original system of equations. 6 times 3 is 18, minus 3 times 2 is 6. 18 minus 6 is 12. 3 times 3 is 9, minus 2 is 7. It checks out. Alright, last, we got our 3 by 3 matrices. Let's go ahead and do the concession stand one. Okay, so I'm going to call my candy X, popcorn Y, pop is Z. So we're going to have 2X plus 3Y plus Z equals $8. 2X, no Y, plus 3Z, $9. And then we have 3Y plus 2Z equals $7. No X on that one. Okay, then we change it into matrices. 2, 3, 1. 2, 0, 3. 0, 3, 2 times our X, Y, Z and our answers. And we A inverse both sides. Those will cancel out. And A inverse times B is what we're going to do on our calculator. So we go second matrix, slide over to edit, your 3 by 3, and we should have 2, 3, 1, 2, 0, 3, 0, 3, 2. And then for our second matrix, edit, edit matrix B. We have a 3 by 1, and we have 8, 9, 7. Okay, we have to do second, quit to get back to this main screen. Second matrix, we stay under names, A, inverse, times second matrix B, 1.5, 1, and 2. And then we're going to make sure we put that in dollars and cents. $1.50, $1, $2. Or as it ordered triple, and there it is. Alright folks, thanks for watching. That should be one of each, and leaving you one of each to do on your own. And that answer key should be posted on Schoology. Go ahead and give those a try and check them out. Good luck on your quiz.